Hello. In lesson 5, we talked about the Pascal's triangle, which we can use to find the coefficients when expanding binomial problems. In lesson 6, we talked about the binomial formula, which we can also use to find those coefficients. And now, in this new lesson, lesson 7, I want us to talk about the binomial theorem, where now we'll combine the formula we talked in lesson 6, the binomial formula, with another formula here to expand the problems like these binomial problems, without the need of the Pascal's triangle. So, finally, after the expansion, we need to see things like this. If I had an example like x plus y raised to power 2, then in the expansion, I would like to see an expanded equation like this. So, can we start with just a simple example? Then I'll explain the formula as we go on by. But before we do that, can you first go to lesson 6 and review this formula so that I don't have to explain it again here on lesson 7. So that here I just explain this new formula. Since we did this one in lesson 6, you can review it. But now in this new one, this whole thing here, a plus b raised to power n, now represents the problem we are given to solve. Like for example here, if I have a problem like this one, a plus b raised to power 3, that is the problem we are given to solve. Or 2x plus 3y raised to power 4 is the problem. X minus 5y raised to power 2 is the problem. So that side represents the problem we are given to solve. And then this n represents the highest power we are given in the problem. Like for example, if I have the first problem here, which is a plus b raised to power 3, let me write it somewhere here, a plus b raised to power 3, then n becomes 3. And then this r will start from 0 all the way to n, whereby n is the highest power we are given. And in our case, n is 3, so r will start from 0, 1, 2, 3, up to the highest power. Then these a and b are the unknowns we are given in the problem. Like in our case, they still retain a plus b, but in other problems, for example, this one, they can change to xy. Or you see also this one is xy, but they can be anything. They can even be m, w, or another unknown. It's not a must to be xy or mb. They are not unique. Then, now that we know everything about that, and from lesson 6 we know how to apply this formula, what this symbol means is we sum up all the expansion from 0, where r was 0, to the highest power, which was 3, in our case, for example. So, if we start doing this, what it means is I start with the first expansion, where r is 0, so it becomes n is 3. Let me call it the first expansion. So, n is 3, and then r is 0 in that case. Then here, this one into n, but now n is 3 minus r, which is 0, then b raised to power 0, which will become 3, 0, 3 minus 0 is just 3, so it will be a raised to power 3, then b raised to power 0 is 1. So if we multiply by 1 here, it will just still remain to be a raised to power 3, but don't forget we have 3 combination of 0, so this is the coefficient. We will solve it later. For now, let's just put all the expansions. So let's go to the second expansion, where now I log 3, but now the second power for r is 1. Then raised to power n minus r, but n is 3, now minus r, which now has taken 1, into b raised to power 1, which now becomes 3, 1, into a minus 3 is just 2, so it becomes raised to power 2, then b raised to power 1 is just b. Then go to the third expansion, where now it becomes 3, and then r takes on 2, yeah, this one. Then here, but n is 3, but now minus 2 into b raised to power 2, now which becomes 3, 2 into here raised to power 3 minus 2 is just 1. So 1 raised to 1 will just be here, because n number raised to power 1 is just the number itself, then b squared. And then we go to the form expansion, which now will take on 3, 3, and because r is 3 now, into a raised to power 3, which is n minus 3, and now b raised to power 3, which now will become 3, 3, into 3 minus 3 is 0. So here raised to power 0 is 1, because n number raised to power 0 is 1. So that one just goes and remains with 3, 3, b raised to power 3. So we already have all the expansion. The first expansion is a cubed, the second one is a squared b, the third one is mb squared, then the fourth one is b cubed. But we don't have the coefficients, though we do have them here, we have not solved them. So can we try to apply now this formula which we need in lesson 6 to get the coefficients? Then after that, we can now do the whole sum of the expansions. So if I start with the first one, which was 3, 0, it will be, now it will be, n will be 3, then 0, which is equals to n, which is 3 factorial, into 0 factorial, I'm following this formula, into 3, which is n minus 0, and now factorial, which now becomes 3 factorial into 0 factorial is 1. I taught this, the logic of 0 factorial being 1 in lesson 1. You can review it. Then 3 minus 0 is 3 on our factorial, which now becomes, if 1 multiplied by 3 factorial, it will just be 3 factorial. So it becomes 3 factorial into 3 factorial, which is 1. Because if I divide by 3 factorial, 1 by 3, 1. So the first coefficient is 1. So we go to the second one, which was 3, 1. Then I follow the same formula. I have 3 factorial into 1 factorial into 3 minus 1 banana factorial, which becomes 3 factorial into 1 factorial is just 1. So 3 minus 1 is 2, but now 2 factorial, which now becomes 3 by 2 factorial all over 2 factorial. I taught this logic in lesson 6, you can review it. So I cancel this 2 factorial with this 2 factorial, and I remain with 3. So the second coefficient is 3. So the third one will be 3, 2, which now becomes 3 factorial into 2 factorial into 3 minus 2, but now factorial, which becomes 3 factorial into 2 factorial is just, I can retain it like that, 2 factorial, then 3 minus 2 is 1. So 1 factorial is just 1. You don't need to put it here. So it can be 3 factorial all over 2 factorial, which should become 3 by 2 factorial. Since I have another 2 factorial here, I can just put like this and cancel it. So that one will also be 3. Then again, I can go to, this was first, second, third. So we got the form which is now 3 by 3. This one, yeah, which now becomes 3 factorial into r is now 3 factorial into 3 minus 3, and now factorial, which now becomes 3 factorial into 3 factorial, 0 factorial, because 3 minus 3 is 0. So you see, we said 0 factorial is 1, so this one will remain to be 3 factorial, another 3 factorial, which will be 1, because I cancel off them. So now I have all the coefficients here as 1, 3, 3, 1. So now I apply this summation here, which just means I pick the first coefficient, which was 1. I multiplied by the first expansion, which was the first expansion was a raised to power 3 plus. I pick the second coefficient, which was 3. Then I multiply by the second expansion, which was a squared b. So it becomes a squared b. Then plus the next one is also 3. Then 3, put 3 here. Then the third expansion, which was a b squared, like that. And then the last one is 1. The coefficient is 1. Then I'm applying by the final expansion, which was b cubed. So my answer becomes a raised to power 3, because 1 multiplied by a cubed is just a cube, plus 3 squared b plus 3b squared plus b cubed. This becomes our binomial expansion for this question here. So can you try to follow the same logic and solve this question 2 and question 3? And you can subscribe to my channel, like and share these videos, so that you can also get new content once I upload it for these mathematical lessons. Bye for now. Let's meet in the next lesson.